In this video, we'll be looking at our final quadrilateral, the kite. A kite is a quadrilateral with exactly two pairs of consecutive congruent sides. In other words, the congruent sides are touching each other. This is different from the parallelogram because the congruent sides were opposite each other on the parallelogram. On the kite, they are adjacent and consecutive to each other. So for example, if this side was 8, this piece would also be 8. If this was 12, this would be 12 as well. All right, some properties of a kite. First off, two pairs of consecutive congruent sides, as we just discussed. Second, the diagonals are perpendicular. Okay, so they form a right angle in the middle. So anytime you see a right angle in a quadrilateral, it means you can get right triangles, which means we have the potential to use the Pythagorean theorem, or 30, 60, 90, or trig perhaps even, to solve for missing sides and angles. Third property of a kite, the longer diagonal bisects the shorter diagonal. So the longer one will cut the smaller one in half. This does not mean that the longer one's cut in half. It only means that the shorter one is cut in half by the longer diagonal. And finally, that long diagonal will also bisect the opposite angles. So it'll bisect the angles that it goes through. So the longer diagonal bisects the side and bisects the angles that it cuts. So let's look at some problems. Here's my kite. This side's congruent to this side, and this side with this side. We know that this piece is 27. So if this piece is 27, then this piece next to it's also 27. Now, what do you remember about the diagonals of a kite? Well, they're perpendicular. So that means that all of these angles are right angles. So angle 1 equals 90 degrees. And if you notice, you have a shape here. This happens to be a right triangle. And so it has to add to 80. So you got 90 plus 27 plus angle 2 equals 180. So 117 plus angle 2 equals 180, and subtract it, and you get the angle 2 equals 63 degrees. And that's how we can solve for some missing angles right there. Notice, we don't know what this other angle is next to angle 2 because we don't know that these are bisectors. So we actually can't figure that one out with the information that's given. All right, so quadrilateral kite is a kite. So SE equals 7 and KI equals 25. If this piece is 7, then SI is also 7 because remember the longer diagonal bisects the shorter one. So what could we do to solve? Well, we already solved for SI. So what could we do to solve for KS? Well, you know that these diagonals create right angles. So it looks like we're going to be using Pythagorean theorem. And first off, identify what's your hypotenuse. So 25 is. So that's what's going by itself. So 7 squared plus x squared equals 25 squared. 49 plus x squared equals 625. Subtract 49 from both sides. X squared equals 576. Of course, we take the square root, so x equals 24. So just like that, we figured out that this piece right here was 24. So make sure that you know that you can use Pythagorean theorem on any questions with the kite as long as you're given two sides. All right, so quadrilateral LMNO is a kite. Let's go ahead and fill in. Actually, I want you to pause the video and try this on your own, and then come back and see how you did. All right, angle MNO. So this whole thing is 72 degrees. And OLM, this whole thing is 98 degrees. So what does this longer diagonal do? Well, it bisects the angles. So half of 98 is 49 and 49. Half of 72 is 36 and 36. Now what are these angles in the middle? They're all going to be 90. So you know this triangle has to add up to 180. So 180 minus 90 minus 49 gives you 41. Same thing here. Then 180 minus 90 minus 36 gives you 54 and 54. So angle MPN, MPN, well that's 90. MLN, MLN, 49. LOM, 41. NMP, 54. And PNO, 36. So that's how we can solve for all the missing angles inside of a kite. All right, so finally, here's my final picture of a quadrilateral family. There's the quadrilaterals, and they have, you can think of it kind of like three kids. Kites, they're kind of by themselves over here. Parallelograms, they have a bunch of relatives. Trapezoids, which go to isosceles trapezoids. So that's it for kites. If you have the chance, please watch the next video where I'll be going over a review of all the properties of the different quadrilaterals. Thank you.